今日試教嘅課題係小六嘅對稱。咁今日會講嘅就係一啲常見嘅對稱幾何圖形，同埋向學生解釋點解圓係有無限條對稱軸嘅。Good morning, class. Welcome back to the mathematics course. And in the previous lesson, we have learned about what is symmetry, right? Let me write it down on the left. Symmetry. So, any one of you can tell Mr. Fong that the definition of whether or not a shape is symmetric or not. Yeah, actually. Oh, you have mentioned a completely overlap. Great, let me write it down. Great. Let me give you the stickers. Alright, so except from completely overlap, so we have learned another. It's the essence of symmetry. And we have learned that actually there are three important points for us when we draw the essence of symmetry of a 2D shape. Okay, I give you first dotted. And the second one will be passing through the shape. And anyone can answer the third one. Macy. Oh yeah, you're right. Bear in mind, we should show all the essence of symmetry. We should show all the essence of symmetry for a shape that has more than one essence of symmetry. This is the plural form, remember? Great. Okay, so we're now moving to a new topic. So I'm not going to have a group work for all of you, but before the group work, I want you to separate in three pathways for a group, okay? Do it now, okay? Three pathways, one group. Okay, I can see. Okay, most of you have done. Okay, great. So, here is the instruction. I want you to read it carefully before we start doing the group work. So, later on, I will distribute a group work paper for you. It's like this. Okay, it's like this. Then, I will give you a graph paper. The graph paper and when you receive the graph paper, you should cut out all the shapes of it like this, okay? I'm basing on under the paper. Okay. When you receive the graph paper, you should cut the shape on it, okay, like this, okay? And so, what about division of labor is that, so, I want one of your group mates to be in charge in cutting the shape from the graph paper. Then, what I want you to do is, after you cut the shape from the graph paper, like this is a rectangle. Okay, we are now going to figure out how many essence of symmetry of a rectangle is. And please pass it to another groupmate so that he will do step 2, floating it in any way to find out the essence of symmetry of the shape. And when second classmate has done his homework, pass it to the third groupmate So the first movement will draw the essence of symmetry of the shape on the worksheet. And this is a cycle. First, you should cut the shape from the graph paper and flow it in any way to check whether or not how many essence of symmetry does the shape have, and finally draw it out on the woodwork paper. And after a cycle, please transfer your responsibility to others. So what do you mean, Mr. Paul? Actually, so just like this book, Brian has finished the step 1, and after he has finished step 1, when we starting on a new cycle, Brian should focus on step 2. He will start to fold the shape to figure out how many essence of symmetry. And during the first cycle, he will be in charge in drawing the essence of symmetry of the worksheet on the worksheet. So I want at least any of you will be in charge with each steps, okay? Okay, so I'm not going to distribute the woodwork paper. And the graph paper as well. Great. So, I give you around 8 minutes. You should do one by one. What I mean is that, okay, let me do another visualization. Like this. Please do the first question and second question, third question, fourth question, and there a star question. But I don't want you to do it now. Please finish all the questions. Then you should start on the star question. Okay. Later on, I will check each of your groups. And group 1. I will check your answer for the first question. Group 2, I will check your answer for the second question. Okay, so all so far. So I'm not giving you 8 minutes to finish all the questions of the group work. Okay, 8 minutes. Go. Remember, cut the shape from the graph paper and flow it in any way. Then draw it on the worksheet. So, okay, 8 minutes, go. Interesting. Yeah, you've done a great job. Yeah. 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 Great. I see most of you are working on the first question already. Great. Some of you working on the second questions already. Okay. Great. Interesting. Okay, you can discuss with your groupmates to see whether or not your assumption is correct. Okay, I can give you a little hint. Some of the shape has more than one axis of symmetry. Some of the shapes do not have axis of symmetry. They are not symmetry. Okay, yeah, go on. Interesting. Some of you are starting on doing question 4 already. Oh, how many axes of symmetry have you found for the second shape rectangle? Oh, okay, yeah. Interesting. What about the book? Next will be presented about the second set, which is the trapeze. Yeah. Oh. Oh. I see your point. Great. Yeah. Okay, carry on. Great. Both we have done a great demonstration. Every one of you should participate in different roles, okay? Don't try to cut all the shape by yourself, okay? You should participate in different roles. Great, great. Okay, I'm now going to check each answer of your group. So, on group 1 first. Yeah. Other groups, please focus on your work, okay? So, group 1, yeah. Oh, square. Oh, that's one interesting finding, right? Yeah. And the second axis of symmetry would be here, right? And the third one would be here. Four. Alright. We can now work on the star question if you have finished the first 7 questions. Okay, good, good. What's your finding? Interesting. Rectangle. So you guys have drawn like this, right? And this. Great. Interesting. Don't ask me to answer, okay? You will know it later. For 3, isosceles triangle. Okay. Oh, let me see. Okay, you draw like this. Alright. Okay, you can now go on to discuss about star question. Alright, group 4. Oh, you guys have been started on working the star question already, okay? But I want to check what is your answer for the question 4? Equilateral triangle. Oh, so you guys only found this, right? Okay, interesting. Okay. Good. 5. Root 5 will be like this, okay. Longest. Great. Root 6. Okay, your findings. Okay, interesting. Yeah. Okay. And let's walk all the stuff. Okay, finally, the last group. Oh, yeah. Alright, interesting. Yeah. Great. Good. Okay, I can see most of you are now working on the start pressure. Okay, I give you around 1 more minutes. 1 more minute. And I will go on to discuss about the answer of it. Okay, ding dong, ding dong. Okay, put down all the pens. Put down all the pens, and we are now going to check the answer. I've checked each of the groups, and let's see what we have found. So for group 1, here. Group 1, they are in charged in square, and they have found actually there are 4 different axes of symmetry of a square. The answer is yes. Congratulations. Yes. It has 4 axes of symmetry. Remember, true or false, okay? And then let's try. They said that the axis of symmetry should be like this. Okay, let me try. I have a identical square here. Okay, roll it. Yeah, completely open. You can see. And the second axis of symmetry can be obtained by this way. Okay, completely overlap as well. We have 2 axes of symmetry, and the third one will be this. Yeah, completely over. And the last one will be this. See? Completely over. Okay, so we can observe 4 creases on the square. Right. So group 1, correct. Congratulations. Okay, let's move on to group 2. Oh, for group 2, they are in charge with rectangle. And they have found there are 2 axes of symmetry. And the answer is yes. Congratulations. Okay. You can try it by yourself. Okay, I don't do it one by one. It's correct, obviously. So for group 3, let's go on to group 3. Group 3, isosceles triangle. They have found that actually there should be 1 axis of symmetry from this isosceles triangle. Yes, that's correct. Congratulations. So, isosceles triangle here. And when we throw it in this way, this, okay? Completely open. And yeah, congratulations. Okay, for group 4, interesting. Oh, they have found that, there should be only one axis of symmetry for an equilateral triangle. It should be like this. Okay, let me try. Yeah, completely overlap. Any of the groups have found a different answer for question 4. Oops, group 6. What's your answer? Oh, you said 3. Okay, so it's 1 or 3. Okay, if you think it's 1, please put up your hands. Okay, interesting. Then what about 3 axis of symmetry? Put up your hands. Yeah. Okay, let me focus back on this. Okay, for group 4, they have mentioned that they only found one axis of symmetry. That is like this. And what Mr. Fong wants to explain, actually, sorry, group 4, you got a wrong answer. Because if we do this, and similarly, just flow it. We can have another axis of symmetry as well. Completely overlap. Completely overlap. And we now have 2. And we can do it one more. Like this. Completely overlap again. Okay, so we can see here, there are 3 creases on this equilateral triangle. Yeah, don't be misleaded by the question 3. There are different types of triangle, and some of them has only one axis of symmetry, but some of them has 3 actually. So actually it's 3. Okay, let me draw the remaining 2. Dotted line pass through the whole shape. And this. Great. Remember group 4, okay? It's not to be shamed that answering wrong, okay? Actually, you have learned a new knowledge. Great. Okay, move on to the fifth question. Group 5. Rhombus. Group 5 has found there should be only 2 axes of symmetry for rhombus. Okay, the answer is yes. Congratulations. Yeah. Okay, great. For group 6. Okay, group 6 has mentioned think that actually parallelogram, they do not think a parallelogram has an axis of symmetry on it. Okay, let me find. Okay, parallelogram. Okay. Let Mr. Fong decide that. Interesting. Mr. Fong thinks that actually parallelogram has axis of symmetry. The axis of symmetry should look like this. Okay, you can see the axis of symmetry should look like this. Okay, let me try to plot it along the axis of symmetry. Oops, eventually, you can see they cannot be completely overlapped. If they cannot be completely overlapped, the shape will not become as symmetric. Okay? So, you can see, I want all of you to do it now. Draw a dotted line on the parallelogram and float it along the dotted line. Okay, I can see group 4 is doing well. Oh yeah, great. I want all of your group to try. Okay? You can see the shape cannot be completely overlapped when we fold it along the dotted line. This will not be the essence of symmetry of a parallelogram. And eventually, group 6 answers correct. No, there has zero essence of symmetry for a parallelogram. Okay, so you should not draw any dotted line, any essence of symmetry on it. Okay. Last group 7. Okay, trapezium. They have group 7 think that actually there should be one essence of symmetry on it. It should be looked like this. Okay, let me try. Oops, completely overlap. Yeah. The crease you can observe. They're same. Okay. Great. But similarly, like the parallelogram, if I float it along like this, you cannot receive a completely overlap shape. Okay, you can see the white part here. You can see the white part here. Yeah, teaming. Yeah. Also, can you observe the white part here? Great. So there are only one essence of symmetry of a trapezium. It's like this. Okay. This is not the essence of symmetry. Great. Group 7. You have done a great job. Alright, so let's move on to the star question. How many essence of symmetry does a circle has actually? Okay, anyone want to answer? Oops. Okay, group 7. So, what is your answer? Infinity. Interesting. Let me write it down on the back. Okay, although this mathematics knowledge should not be taught in primary 6, but I can see some of you actually write down the symbol of this. Yeah, actually, a circle has infinity number of essence of symmetry. Okay, so maybe you guys can wonder, oh, it's the whole. Why? Circles has infinite number of essence of symmetry. Okay, let me do a demonstration here. You guys have learned circle in your primary 5, right? Okay, so I got a circle here. Okay. So, may I ask, Chris, what is this? We call it as a center, right? Center. The black dot here is a center, and figure is thickness. Great. Okay, so this is a center. Okay, let me do something interesting. So, if I draw a line here, any one of you can tell Mr. Paul what is this? Over here. Diameter. Yeah, diameter. Let me write it down on the diameter. Great. Stickers. Great. So, actually, if we flow along to this diameter of the circle, actually you guys will receive a completely overlapped shape. You can see, I flow along the diameter. Yeah, and completely overlap. So, and another diameter. And similarly, let's draw it along this new diameter. Okay, for this new diameter, we still can receive a completely overlap shape. See? Yeah. And for this new diameter. And further. Okay. Flow along the third diameter. Completely overlap. Okay. You can see, right? Completely overlap. Okay, may I ask a question? Brian, actually, how many diameters can we draw for a circle? Many. Yeah, many. Actually, you can draw unlimited diameter from a circle. Let me give a status, right? Alright, so if we can draw different we can draw infinity numbers of diameter of a circle, which means actually the diameter is actually the axis of symmetry of a circle as well, which means we will have infinity numbers of axis of symmetry for a circle. Okay, I have to write down on the blackboard. Okay. Please take out your password book. Please take out your password book. I want to write it down. Great. Okay, please write down on the password book. Circle has infinity numbers of axes of symmetry. Yeah, because we can draw unlimited diameter of a circle, and diameter will be axis of symmetry of a circle as well. So we can conclude that a circle has infinity number of axes of symmetry. I give you 30 seconds. Please write it down on your password book, okay? Okay. I've flown it by set, actually. Please look at the screen as well. Okay. Actually, you can observe that when I float it, this will be the axis of symmetry. And you can see there are so many creases on this circle. I cannot count it actually. How many? I really don't know. So for the star questions, actually, yeah, circle has infinity number of axis of symmetry. But actually, you can also write down. So as you know, okay, infinity. Great. Yeah. So interesting. So let me go through for today's lectures. Okay. So infinity, or actually, you can write down this symbol as well. But if in exam you can write down much is already enough. Okay. So before we go to the revision, I'm going to distribute you the homework tonight. The homework tonight is you are now able to do this to figure out whether or not this shape is symmetric and whether or not these dotted lines are the essence of symmetry of a shape, and yeah, as well. Okay, now I will distribute you the revision card. Okay, actually they are same as the today's group worksheet, but I want you to complete the revision card by yourself. Okay, this will be this revision card is for you to tackle the exam. Okay, the coming exam. Okay, remember. Okay, you are now able to answer the 8th question. How many aspect symmetry of a circle has? So let Mr. Fong to go through to give you a little summarize of this lesson. So we have learned that actually there are different shapes that is symmetric, like square, rectangles, triangle. But some of the 2D shapes they are not symmetric, like trapezium or parallelogram. Okay, but also there are unique conditions. It says one shape has infinity number of aspects of symmetry. That is circle. Okay, remember to write this down on the class workbook. Okay. Okay. So it's almost time. So stand up. Goodbye, class.